title the next part of today's lesson, Inverses, Who Cares? Let's turn to the next page, and you'll see why this is actually helpful for us.
Is it helpful IRL, or just in math talk?
What does IRL mean?
In real life? Am I ever going to use this outside of this classroom?
Is there anything that we learned in this class that you're going to use outside of this classroom?
Remember, this is all made up.
Yeah, it's all...
Fair game. Forgot about that.
Yeah, like in college, they've never even heard of like determinants. So, if you become, I don't know if you think of going into business, or like economics. There's a lot. Matrices are used quite a bit there. I can go into more detail than you want on that, but right now, let's just start with this will be helpful non-IRL. Okay. Beginning with. I want you to go old school. I want you to solve something that you could have solved back in Algebra 1, which is this system of equations. How would you do this one? Would you do a substitution, like get a variable by itself and plug it into the other? Or would you do an elimination, where you take one of the equations and you multiply it by a number, and then you add them together and something cancels out? I wouldn't do substitution because there's no variable that you can get to without making fractions. So how about we take this one and we multiply it by something, and I want to multiply it by something so that the negative 2 will go away. So let's say, Hunter.
I think multiply it by 3.
That's a good idea. Except for, I think you want to make it a negative 3. So that over here now we've got negative 9x plus 6y equals negative 60. And you've got 5x minus 6y is equal to 36. And you take those two equations and you add them together. Remember that stuff? Okay. So our 6y's, when we add together, they go away, and what we're left with is a negative 4x and a, what's that going to give us? Negative 24. So x is equal to 6. All right, so we want a point where x is 6. Let's see, what would y be? What would you plug x into? The first equation or the second equation? Which one would you guys choose? Either one will work. Which one would you choose? Okay. I would probably choose the first one just because the numbers are smaller, but either one will work. So 3 times 6 minus 2y is going to give us 20. So negative 2y would be equal to, let's see, that's 18. Take that away, so we've got 2. So y is going to be equal to negative 1.
Mr. Klein, can I just say, when this came over to me, I forgot how to do this now. And now, so then we always have these one of these problems.
Now you're back in the game?
Now I'm going to get that point. Let's go.
Okay, now I'm going to show you how to get that point using matrices.
Oh.
So check this out. Imagine that what we really have here is a matrix multiplying a variable, x is a variable, right, to get another matrix, which we'll call B. Let's start with the B matrix. That was the easiest to see. The B matrix is a 2 by 1. Can you see what the two terms in it are going to be? Yep, 20 and 36. On the other side, we have a 2 by 2 multiplying a 2 by 1. The 2 by 1 is the x matrix, so we need variables right here. Hey, what two variables are in the problem? X, y. Now, if you look at the first equation here, a 3 and a negative 2 are the coefficients of x and y, correct? Mm-hmm. So 3 and negative 2 are going to go right there. 5 and negative 6 are going to go right here. So step 1, do you believe me that this is really the same as this? Okay. If we multiplied this by xy, you would get 3x minus 2y in the same position as 20. Okay, we good with this? All right. Now, we want to figure out what x and y are equal to, correct? Say what? Okay, which means we need to get rid of a.
Well, what can we multiply a by and we get the grade? That question